this lesson deals with looking at other types of concentration. You've already learned how to calculate molar concentration, and that is the most common way of calculating concentration in chemistry, because the mole is king in chemistry, and that is a very useful way of actually describing the concentration of a solution. But there are other ways of finding concentration that you find in a lot of products. So for example, I've given some examples where these are found in commercial products. And sometimes you see different kinds of concentration when we look at solubility, which is a topic that is coming a little bit later on. Now, what they all have in common is that they deal with the amount of solute over the amount of solution. But what they're measuring is a little bit different for each one. So the first ones we're going to look at are percent concentrations. So these are all going to be expressed as a percent. There are 3 different kinds. So the first one is percent by volume. And so its symbol is percent VV. And you can see that we've got mils of solute over mils of solution times 100. And for example, this is used, I've got the example here in the suntan lotion. Vinegar comes this way. Hydrogen peroxide, I've ever seen the bottle and it says 3% hydrogen peroxide. Basically, they're using percent by volume. The other one is percent by mass, which is the correct term, also called percent by weight. And so these are the symbols, percent WW or percent MM. This is grams of solute over grams of solution times 100. And percent mass volume is going to be the percent, basically the mass of solute over the volume of solution times 100. Now, I hope that you guys are seeing some similarities here. Because these are percents, you are multiplying by 100 in each of these 3 examples, so you will see that. And the other thing that I hope that you've noticed is that the units are mils and grams. Not that it matters if you've got mils over mils, as long as both units are the same, it's going to work out. But usually you'll see that when we write them, they're written as mils and grams are the units that we use with these. Now, the other kind of concentration we're going to have a quick look at are parts per million. And parts per million are used when you've got very small quantities of solute dissolved in a large solution. And so for this one, the formula is grams of solute divided by grams of solution. So no different than percent by mass. But instead of multiplying it by 100, you're multiplying it by 1,000,000, hence the parts per million. And the symbol that we use for that is ppm. Now, there is a couple of other ways of doing parts per million calculations, and I've just written them here at the bottom of the table. And they make doing the calculation a little bit easier. So they get rid of the 10 to the power of 6, which is sometimes unwieldy to work with. And so the other 2 ways of doing this formula is milligrams of solute over kilograms of solution. So by changing the units in the formula, you get rid of that 10 to the power of 6 unit, which makes it a little bit easier to use. And there's 2 versions. One when you have the mass of the solution, and one when you've got the volume of the solution. So we'll do an example with that as well a little bit later on. All right, so now that I've looked at the table, I'm going to scroll back forward to the questions that we are going to go over for this. So example 1 says, a brine, which is another way of saying salt solution, is prepared by dissolving 3.13 grams of sodium chloride to make 20 mils of solution. What is the percent concentration in percent mass volume or weight volume for this solution? So I know my mass is going to be 3.13 grams and my volume is 20 milliliters. So my formula is percent, and I'm going to go mass volume because it is a little bit more correct than weight volume. And this is basically the grams of solute. And I do have those as my units. over the mils of solution, which is also the units that I have, which is great. And this is going to be times 100 because it is a percent. So I'm just going to substitute in, and this is 3.13 grams over 20 mils times 100. And this turns out to be 15.65%. To 3 significant digits, which is what my question has, this is going to be 15.7%. You can just leave it as a percent, or you can write mass volume if you want to be a little bit more accurate. All right, so that's our first example. Our second example looks at parts per million, and parts per million I think are a bit of the tougher questions with this, although like I said, we are going to keep it simple by getting you to just find the concentration. We're not going to have you work back to the original numbers that we used to calculate it, so it will make it easier. So it says sulfate ions, SO4 2-, in drinking water should not be found at a concentration higher than 500 parts per million. What is the concentration of sulfate ions in Calgary's drinking water if 250 grams of water contains 0.0145 grams of sulfate ions? Is it within safe limits? So here it's telling me that a 250 gram sample, so that's going to be my mass of solution. And that's going to be 250 grams, has 0.0145 grams of sulfate. So that's my grams of solute. All right, and now I'm ready to solve. So parts per million, the formula is grams of solute over grams of solution. And because it's not percent, it's per million times 10 to the power of 6. So substituting in, this is 0.0145 grams divided by 250 grams times 10 to the power of 6. And this turns out to be 58 parts per million. Okay, and technically 58.0 parts per million. So that's our unit for parts per million is ppm. Now, the question is it within safe limits? Well, yes it is, because 58 parts per million is lower than 500 and it is safe. So by the way, those are real numbers from the City of Calgary website and our water quality. So we do actually have a water that is within the safe limits for sulfate. All right, our third example. This third example, I'm actually going to calculate in 2 ways. I'm going to use our typical parts per million formula, and then I'm going to use one of the other ones that I talked about a little bit. So it says calculate the parts per million of the carbonate ion present if 113 milligrams of carbonate are present in 500 mils of water. So I've got to do a few things here. First one is my mass of solute. And remember, for the formula, it's got to be in grams, or at least the 2 units have to be the same. So I'm going to change milligrams to grams. So 113 milligrams. To change it to grams, I move my decimal place 3 to the left. And so this is 0.113 grams. And by the way, you can also divide by 1,000. It does the same thing. And I hope you notice that that is the same as we did to change from milliliters to liters. We're doing exactly the same calculation here, except that it's grams. So it's milligrams to grams, divide by 1,000, milliliters to liters, divide by 1,000. Now, I'm going to need the mass of my solution. And with parts per million, the volume of water, or the mass of the water, is what we use because there's so little solute that we can assume that that's a good representation. So I've got 500 mils of water. Now, I need to change that to grams. And so what you need to know here is that water has a density of 1 gram per mil. What does that mean? It means that 1 gram of water or 1 mil of water weighs 1 gram. That's basically all that it means. So this is a 1-to-1 kind of relationship. So 500 mils is going to be the same as 500 grams of water. And by the way, this is for water or other substances that they tell you that the density is close enough to water that you can use that number. Most other substances have a density that's either going to be higher or lower than that of water. All right. So now I'm ready to find it in the first way. And again, I'm going to do it underneath here and leave space for another one. So parts per million is, again, grams of solute over grams of solution times a million. So this is 0.113 grams divided by 500 grams. I changed that volume into grams times 10 to the power of 6. And this turns out to be 226 parts per million. So that's the first way, and I needed to change my mass from milligrams to grams, and I needed to change my volume into a mass. Not that it's that hard to do, but there's another way of doing this. So if you recall, the other formula that I can use is parts per million equals milligrams of solute over liters of solution. And I can ignore that times 10 to the power of 6. So here, I can actually go back to my original mass, so 113 milligrams, and I divide that. Now, I can keep it because it's liters. I just have to change my milliliters to liters, which you all know how to do by now. And I get exactly the same answer. All right? So either way works, and this this type of formula is a lot easier to use if I was asking you to find the amount of solute or the volume of solution. But since we're only finding the concentration, not as critical, but I wanted you to be familiar with it. All right, example 4. And example 4 is where I want you to feel or start moving towards, which is where you're changing from one unit to another unit. So you're converting from one unit to another. So it says vinegar sold in stores has a concentration of acetic acid of 2% volume. And it says calculate the concentration of the vinegar above in grams per liter. And it says assume the density of vinegar is the same as that for water. So this is what this means, and this is the important part with this that I want you guys to get from this. So 2% volume means that I have, remember, 2 milliliters in 100 milliliters. That's what 2% means. And because this is volume, my units are going to be both in mils. Now, what I need to do is I need to change the concentration of the vinegar into grams per liter. So the first thing that I need to do is I'm going to tackle the top first, because this is going to be a 2-step process. So I'm going to tackle the solute first. And it says, assume that the density of vinegar is the same as that for water. And remember I told you that the density of water is 1 gram per mil. So what I can do is, again, I'm going to use a ratio. I'm going to put mils at the bottom, grams at the top, and I know that this is going to be 1. So now what I've done is I've used my density to change my number, and now I have 2 grams per 100 mils. So that's step number 1. Now, I can continue on, and I'm going to take this number, and I have to change my other unit to liters. So this is, again, where I need to know how many liters there are in a milliliter. But again, I want these units that cancel out across from each other. So I know that milliliters is going to be on the top here because I want the milliliters on the bottom here and the milliliters at the top to cancel out. Now, I know that there are, and I'm looking for liters. Oops. So I'm looking for liters. Now I need to know basically my conversion factor. So I know that there are 1,000 milliliters in 1 liter. And you should know that too, because you know that you're either multiplying or dividing by 1,000 to go from milliliters to liters or liters to milliliters. So this means that my milliliters cancel out, and take a look at the units that I'm left with. I'm left with grams per liter. Okay, there is no formula for this. You really have to be able to analyze your units and come up with appropriate ratios to figure out how to do the conversion. So then all I have to do this is just, do the math. So 2 over 100 times 1,000, that's basically what it turns out to be. And this turns out to be 20 grams per liter. By the way, you can do this in one step. And so I'm going to show you how to do that. So 2 milliliters per 100, that's what mils, that's what 2% means. I then am going to use the density, and that changes my units to grams per mil. And then what I'm going to do is do the last step all at once. And basically what I can do is just do all the steps together. I like to put them in brackets in my calculator like this. Okay, and you end up with exactly the same answer. So in terms of calculating other units for concentration, it's pretty straightforward, and what we're doing is very straightforward because we're always going to get you to find concentration. We're never going to get you to find the amount of solute or the amount of solution. The only place where this becomes a little bit more challenging is when you're changing one unit to another. For the percents, and also, by the way, the parts per million, you're always going by definition. If it's percent, it's something over 100. If it's parts per million, it's something over 1,000,000, basically. And then you're going to use your knowledge of how to do conversions to actually calculate the concentration that they want you to find. So I hope that this was relatively straightforward. By the way, if this doesn't make full sense to you, I wouldn't worry about it. This is a really minor part of what you need to know in this unit. I'm much more concerned that you understand how to calculate molar concentration. That is what you're going to see from here on in the course, and also in any other chemistry course that you take. So do focus on the molar concentration more than this kind of concentration. It's part of the course. I will be testing it, but in a very minor way as we go through.